And welcome to another episode of the Concrete Logic Podcast. And I am totally pumped to have Tyler Lay on. He's, as my kids would say, he's a YouTuber, would be one way to describe him. But he does so much more. But you got to check out Tyler Lay's YouTube on concrete. He is what he likes to call himself, a concrete freak. But Tyler, what did I miss? What else could you say about yourself?
Seth, thank you so much for having me, man. It's exciting to be here. And Baker Concrete has been a big influence on me, been very, very helpful to me several times in my life. They actually gave me a scholarship when I was a grad student that helped pay the bills. So big thanks to Baker and for you for all your help. But I'm a professor at Oklahoma State University. I live, breathe, sleep, dream, do research, teach, you know it, about concrete. I am a concrete freak, right? That is what I'm all about. I've got a YouTube channel out there, www.youtube.com/Tyler Lay. I've got about 300 videos on there. I get about 10,000 views a day on a good day. And I've got about 90,000 subscribers. And if you can get me to 100, that would be amazing, because I get like a play button. I get like it's like a WWF belt, but it's for like YouTube, and I can wear it around my house and stuff. It's going to be amazing. So I'm super pumped about that. And man, I have research projects with a bunch of different, from federal organizations, state organizations, private companies. I am all about concrete. And about my background. I've worked for Texas Department of Transportation as a design engineer, also doing some field stuff for them as well. I worked for Zachary Construction as a field engineer, and that was amazing experience. I also worked for several other design consultants, and then I've been at Oklahoma State for about 15 years. And yeah, baby, let's talk concrete.
Yeah, so Tyler's probably the biggest fan of concrete I think I've met to date. I wanted to. I mean, there's so many things that I would want to talk to you about, Tyler. But today, I think what I would like to talk about is the carbon neutral concrete and trying to define what that is. That's kind of the hot topic of the year, I guess. I've had a couple guests on the podcast, and we've all kind of beat our heads against the wall trying to figure what that is. So, Tyler, could you kind of frame it from where you're sitting? What you think carbon neutral concrete is?
Yeah, so I think that the concept here is that for every pound of Portland cement, it emits around 0.9 pounds of CO2, and we would love to reduce that number to be as low as possible. And some people have thrown the number out there, carbon neutral. Now, if you go in and dig into the numbers, I think carbon neutral is a dream right now. It's something that maybe we'll achieve someday, but let's just talk about making it better at first, and then let's talk about how to make it carbon neutral. So the way you make it better is you reduce the energy during burning. Okay, that's a big thing. And there's lots of different ways to do that. Natural gas burners. People have talked about fusion burners. There's some concept about using some solar panels to do the burning and stuff like that. So there's some cool ideas out there about that. And then the other way to do it is to reduce the amount of clinker. Like what? What's clinker? I thought we were talking about Portland cement. Well, clinker is the stuff that comes out of the kiln. Okay. Clinker is the product from burning limestone and sand, a little bit of aluminum and a little bit of iron together, right? It's one of the part of the magical materials that makes cement amazing. So if you can reduce the amount of that clinker, then that is getting us closer to our carbon goal. So because one of the big challenges is that when you take limestone, that's like calcium carbonate, and you burn it, it reduces that carbonate. It reduces that, it relieves and lets off that CO2. Anyway, so you can do things like use Portland limestone cement. All they're doing there is they're blending in limestone with the clinker. So in the past, you would take clinker, add gypsum, and you'd have Portland cement. Now we're taking clinker, gypsum, and adding in some limestone. About usually around 5% to around 12%, usually in North America right now, in that range, and that's a great tool. That will reduce the amount of clinker you have inside your Portland cement, because it replaces it with limestone. And I know you're probably like me, Seth. First time I heard this, I was like, "What? They're adding gristle to my meat? Like, what's going on here? Like, how am I going to get? Are they diluting it down? I've got a YouTube video about this, but they actually grind the limestone in such a way that it better packs, and it acts as a nucleating point. What? It helps with hydration. All right. And it forms some other products that I'm not so sure if they're as valuable as people say they are, but they're out there. And they design it so it's supposed to be a no change in performance. No increase in strength, no decrease in strength, no increase in set time, no decrease in set time. It's supposed to be neutral. Now, is that possible? I mean, seriously, bro. I mean, can you take something, add something else, and grind it and make it totally no change? I mean, I think that's a little far-fetched. Now, I do think there probably won't be a lot of change, right? And I do think we all owe it to ourselves to check that change for ourselves, right? Mm-hmm. To get out there and evaluate it, trial batch it, play with it, put our hands in the mud, see what's going on. And I think there's a lot of people around the United States right now that are doing that. And I'm hearing a lot of stories that, Portland limestone cement doesn't work for me. And maybe people are just trying to dial it in locally, or perhaps there's a difference in performance, but that's one thing. I've talked a lot, Seth. Come on now. What do you think? Have you dealt with PLCs? What are your thoughts?
Oh yeah, it's so we had Lehigh on the podcast. Stephanie Hampton, shout out to Stephanie. We had her on the podcast early, and she was telling us how Lehigh is converting a lot of their plants to the just pure limestone, doing the 1L cement. So. And in my area here in Virginia in the Mid Atlantic, it's becoming more prevalent. So a lot of these suppliers here in the area are having it available. I did talk to, I think I mentioned this before on another podcast. I did mention to one of my favorite ready mix suppliers in the region, and I said, "Hey, what's going on with this 1L? What's going on with the Portland limestone cement?" And he's like, "We've been using it for years." He's like, "If it's here, we use it. If it's not here, we don't use it."
Right. So I think the good ones. I think that's a great attitude. You know what I mean? Mm-hmm. And just tweak and adjust. And I tell you, in Oklahoma, we've had it for years too. And for me, in my lab, the local material that I've used, it looks just like Portland cement, tastes just like Portland cement. Yeah, I've tasted it. And it performs in concrete pretty much just like Portland cement. Like, I don't see, there might be a little bit of water demand difference, okay, but it is so local to what limestone source they're using and mm-hmm. how they're grinding that limestone source. All right. And there is going to be this tweaking period, but I'll tell you, I know people will get to success. I know they're going to get to this point where it's not that big of a deal. But, Portland limestone cement is awesome, but you asked me about carbon neutral. Well, that's only about an 8% reduction in the overall carbon footprint. And you'd say, well, why is it 8? Why is it not higher? Well, most of the plants on average aren't always going at the highest rate. And they also have to grind the material longer and to make it the right fineness. Okay. And so because of that, grinding is more energy. So that's not the same carbon neutral footprint. So the other things you can do out there is stuff we've done for a long time. We can use SCMs like fly ash and slag. Silica fume is helpful, but silica fume only replaces a very, very small amount, but of your cement typically. But there's things like natural pozzolans out there that people are talking more about. There's things like ground glass that also people are getting excited about in certain regions where it's available. And then there's reclaimed fly ash, which I am working tons and tons and tons on. Okay, and I think reclaimed fly ash is going to be an amazing, amazing tool for us, because this is fly ash that, for did you know, for years and years and years we only used about 50% of the fly ash that was produced every year. That was it,
So
about 50%,
yeah.
and it wasn't because the other 50% was bad, right? It was just because there wasn't the demand. That we didn't have the capacity to use it inside concrete. So what do you do with it? Well, you put it in a landfill, right? You put it in a landfill on the power plant site, and you just landfill it. Well, people are going back in and harvesting it, taking the material out, um, doing different things to it to gussy it up to make it concrete ready. And there's a number of different reclaimed ashes that are being commercially used in the United States. I think Virginia's got some, right?
Yeah, I was about to say, locally here, they just had a little bit of back and forth with the government and the local energy group here about pulling out one of their spots they were storing all that fly ash. So yeah, there was a lot of pushing about exposing it and digging it back up, and how many trucks of it was in there and all that. So I think, like you said, I think eventually they came to their senses and say, hey, we can take this stuff out, reuse it. So I'm sure someone's making some money off of it. So
Yeah, and I think what I can see is that it's extremely consistent because it's been processed. You know what I mean? So fly ash has always gotten a little bit of a bad name, is that you don't know what you're going to get truck to truck. It's not as consistent as cement. And I'm not saying that this material is going to be as consistent as cement. I'm not saying that. But it's going to be more consistent than what we've had in the past with fly ash. And so I think it's another great tool. Okay, it's another great tool to help us get better. But even if you do well, and then I guess on top of that, on top of SEMs, I think SEMs are amazing. They'll get you about a 30 to 50% reduction in the carbon footprint compared to like a straight Portland cement mix. Okay, I mean, so if you went up to 50% slag or 40% slag and 20% fly ash, and I realize I'm saying some things that might be blowing to people's minds, like slag and fly ash, like holy cow, really? Well, if
yeah,
you really want to get carbon neutral, that's the type of stuff that people are going to be doing. Then that'll get you about a 50% reduction. But still, if you add the slag or the SEMs plus the Portland limestone cement, that's still about a 60% reduction. We still got that other 40%. What are we going to do about that? Well, you can get a little bit more out of it by optimizing your aggregation. Okay, and I've done a ton of work in the past. If you haven't seen my tarantula curve mix design tool that's out there, you should check it out. You can find it at www.tarantulacurve.com. Right, but it's free. It's easy. It's widely used in the industry. It's a very cool tool that again will help you reduce your paste in your mix, and your paste is your water plus your binder. So if you can optimize your aggregates, then you can drop those things down even more, and you can drop it down about 15 to 20% over a non-optimized mix. Okay, in that ballpark. And so I'm not sure on all those percentages the best way to add them all up, but the point is we're not to zero.
mm-hmm. Yeah, you're about
So how are we going
halfway
to get
there.
to zero?
Yeah.
So people have talked about carbonation. Do you know what carbonation is, Seth? Have you heard about it before?
Are you talking about like the Carbon Cure guys?
Kind of. This is a little bit different. This is a Carbon Cure. I've tested Carbon Cure, and I think Carbon Cure is a really, really cool technology, and I think we should try to use all kinds of technologies, okay, to try to make our concrete better. But this is a different carbonation. This is where if your concrete is in place, okay, that over time your concrete will suck up CO2 from the atmosphere.
Right. Yep.
And that's been known long time, like longer than I, long time. And that's always been a negative thing. That's always been a bad thing. And the reason why it's bad is because when it sucks up the CO2, the concrete loses the ability to protect steel inside of it from corroding. Like the steel will corrode just like the steel corrodes in air. One of the amazing tools of concrete is that it's super high pH, and it actually pacifies the steel. Okay, so the steel stops corroding inside of it. But if it carbonates, that's no longer the case. Got a YouTube video about that too. But anyway, it's about dragons and knights and concrete, of course. But so people say that well, some of the CO2 that the concrete made, or that was made to produce the concrete, is going to be sucked up during this carbonation. And I think that's true if it's outside and if the surface is well exposed to the atmosphere. You know what I mean? Because in a building, I'm not convinced that all the insides, all the innards, all the beams, all the slabs that have coverings on them, are going to really be taking up CO2. I'm not convinced.
Yeah.
And I think even some of the outside stuff, I think some of the models, I'll just say, are too liberal. Okay, I think that people are assuming. But even with all that, we're still not zero. Okay, so how are we going to get to zero? The best things that I've heard is that if we go back to the very beginning of what I was talking about when you take limestone and you take sand and you take a little bit of iron and a little bit of aluminum and you melt it inside the kiln and you produce that CO2, that you catch that CO2 in the smokestack and you do something with it. Mm-hmm. You turn it into aggregates, turn it into limestone. People have talked about that before. And then you can burn it again. Okay. People have talked about turning it into some kind of cement. Never seen any of them work. Okay. But they've talked about it. Or maybe you turn it into something else we haven't even talked about or thought about, right? Maybe it's food for plants or something else, So if we're ever going to get to zero, that's going to have to be part of the equation.
Yeah.
And I don't think anyone really knows what that looks like right now. So I'm not in charge. You know what I mean? I'm not in charge and out there and talking about it. But for me, I think it's a little premature to say that we're going to get to zero because we don't necessarily know how. Mm-hmm. But I think that's the goal. And I think it's fine to talk about stuff that we don't know how we're going to do yet, right? I mean, it's cool to push the next generation and push the researchers and dream and think about what's going to be possible. Mm-hmm. But from where I'm sitting, I don't see how we're going to get to zero anytime soon. But there's other things we can do. Just make super durable concrete. Make it super long lasting, And I think we as a society have to realize that life costs us stuff. You know what I mean? If I'm going to go to lunch today out at a restaurant, I don't expect to go for free, of course, unless you're buying, Seth. But that's another story.
I don't think that can happen today.
But
unless you take Venmo or something, I'll send it over to you.
There you go. But I don't expect to get stuff for free. I expect to have to pay something. And I think that's how when you start thinking about carbon, it's another cost. Just like money is, just like time is, it's a resource. And we got to figure out how we're going to use it, right? And we need to be wise how we use this carbon, this concrete. But I'll tell you, the investment in concrete is some of the best investments you'll ever make in your entire life. I mean, this material that needs almost no maintenance, this material that's going to outlast you and me, okay? It's going to be around for our kids and our grandkids to be around forever. I mean, that's where we need to be putting our money and our time and our people and our focus, is a gift to future generations.
Right.
But to do it haphazardly, I think it's a massive mistake. You know what I mean? I think that's where we're going to get in trouble.
Yeah, yeah, we're gonna lose sight of what we're doing. I think, like you said, if we can start thinking in terms of instead of 5 or 10 years, start thinking about 50, 60, 70, 80 years down the road, that what we're building we want still standing, um, then maybe people will come to their senses and say, hey, maybe this concrete stuff isn't so bad after all, you know?
No, man,
Because
I think you're exactly right, and I think once we design, we think about repurposing. You know, I
mm-hmm.
mean, so it's a parking garage now. Can I turn it into a condominium? You know what I
Yeah.
mean? Or is there a bunch of different things? Could I take it apart? You know,
Mm-hmm.
I mean, we talk about precasting to put things together quickly. Is there an easy way to take it apart and reuse it? You
Yeah.
know, and so those type of, I mean, those are really cool ideas, and I love your concept about thinking into the future. We're not used to doing that as a species. You know what I mean? We're like,
No.
I'm thinking about lunch because I'm hungry. You know what I mean? So, um,
Yeah, no, it's a struggle to get people to think like that it is an investment versus, you know, we're I've asked other people before, and I'm trying to figure out who we're trying to appease with all this effort that we're putting for carbon neutral concrete, and um, I haven't heard uh, a good answer yet. So, um, but yeah, I think we beat that horse, Tyler. We're not going to solve carbon neutral concrete today. But what I do like, and what I'm hearing from you is we need to be practical about what we're doing, and there's, like you're saying, we can supplement cement or offset cement by using different materials. But every time I hear that, all I keep thinking about is all the conversations I've had with structural engineers in the past, and they're like, no, 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 no. This is the percentage of each you're allowed to utilize in the mix design. You can't go beyond this. Um,
well, you know, and I really appreciate what you're bringing up there. And I have a video on my YouTube channel where I try to give people a calculator where they can. It's very practical. It's very simple, and you could say, "Oh my God, it's missing this." I was like, "Yeah, I know, dude. I'm not here to get everything right. I'm here to give people a tool that they can simply use or whatever." Um, but it has been. I did that tool because I gave a talk for the New York City Structural Engineering Association. Okay, and they were exactly what you just said. They were like, "No, no, 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 no. This is the only amount you can have." And I started to say, "Why are those limits in there? What are they really for? Which one do you want more? Do you want lower CO2, or do you want to have controls on these limits, you know? Because in the end, the thing just needs to taste good. You know what I mean? It just needs to work. You know, you don't over constrain people. Just tell people what it is you want. And if you want low carbon concrete, people can give that to you. They can. There's tools out there to do that. And here's some simple calculations that you can do to prove it to yourself, you know? And, but I think what you're bringing up is right on. There's going to be plenty of change ahead, and communication is going to be, and patience is going to be more important than ever in our industry, you know, and education is going to be more important than ever. And Seth, that's why I think it's great that you're doing this podcast, is to kind of get these ideas out there and talk to people and discuss with people about these things. So I want to, commend you on that.
Well, thank you. And yeah, that's the goal, just to get people to talk. We're not here to solve it. We're just here to discuss it, and debate about it and get some balance into what's going on right now. Before we got started, Tyler, before we hit record, we were talking about what we're going to talk about, but I wanted to talk about 3D printing and your angle on it. So could you share on your project that you're working on? Because I think it's very unique to what we're seeing these days.
Sure, Seth. So the short story is, about 4 years ago, my dean who's a concrete guy, Paul Tukowski, challenged me to teach a new kind of class at Oklahoma State University, a multidiscipline class, one that would cover mechanical engineers, electrical engineers, civil engineers, architects, everybody. He said, "Can you even come up with something?" He had no idea. He said, "We need this because we need to bring all of our disciplines together. We should be working together, not apart." And so I went off and I thought about it, and I was like, 3D printing would be a great thing to work on. So for the past 4 years, I've been teaching a class about 3D printing concrete. And we've built 5 different 3D printers, okay? And 4 of them were junk, right? Not when I say junk, they did some good things, but they weren't going to be where they needed to be. And we realized pretty quickly that 3D printing with mortar, at least in my opinion, is not, I'll just say, sustainable for the future. I think it's too costly. Carbon footprint is too high. It cracks. It's not durable. So we needed to find solutions that did real concrete with large aggregates. And then not having rebar in your concrete, like, that's kind of a little freaky, right? To do that. And some of the 3D printing with mortar, they'll come back and add rebar after the fact. They'll add rebar and fill up the void space that they left before. But I said, well, why don't we just do it all at once? Why don't we just do the same time that, just print around rebar with concrete. So it took us a long time to get there, but we're able to do it now. And we can use ready-mix concrete to do it. I need to make a YouTube video about it. We've been kind of holding off a little bit till things were a little bit more figured out. But it's this device that goes on the front of a traditional piece of construction equipment, okay, something like a track loader. And a human drives it right now, and it uses ready-mix concrete that comes in one side, and it extrudes the material out the other side, so it's closer to slip form paving, okay? And we've done 9-foot high walls with it. We've done doorways with it. We've done windows with it. We print around number 4 rebar, right? That you tie normally. We're working up towards ready-mix concrete. That will be very, very soon that we're able to do that. And the cost is not crazy high. There are some additives that people are not used to using inside concrete that we use. And it's a totally different way to think about concrete mix design because you have to really think about how all the particles kind of interact and pack together. But it's been fun. It's been rewarding. And I'll tell you what, man, it's been crazy because when you do something that people aren't used to seeing, their brain kind of like has a spasm in front of you. You know what I mean? And they don't know how to think about it. But I think it's got potential. It's not perfect. It's not perfect. There's still things to figure out. Don't think I'm saying that this is like a home run. We're done. Okay. I'm just saying that I think this is a better approach. Okay. But we don't have high paste content concrete, okay? It doesn't shrink a lot. It doesn't crack a lot. You'd look at the mix design and you'd be like, wow, that looks like normal concrete. You know what I mean? And we can order it from ready mix, like eventually. We're not there yet, but within a couple of weeks, we should be there. Right. So it looks good. And it finishes, and you can finish, if there's a flaw in it, you just take your trowel right out there and fix it while it's still wet. You know what I mean? You don't have to wait or whatever. You don't have to wait till you yank the forms off and be like, oh no.
Now it looks like
look at the honeycombing. Look at all the patching we have to do. You know what I mean? You'll know the patching immediately that you have to do. And there's not a lot of patching when you get the mix right. And we're trying to make it more robust and improve it and things like that.
So what I imagine, and I know you're not sharing a whole lot about it, and I appreciate you explaining what you're working on. So it's basically concrete without the formwork, right? Concrete construction without the formwork. And formwork is a big cost in concrete construction. So even though you're saying it may cost a little bit more as far as the ready mix, the concrete itself, because you got to add supplements or whatever to it. but you got to subtract the labor cost and the material cost for the formwork. So it may
And it's
be,
fast, man.
yeah.
I mean, as soon as you can tie the steel, you can start printing. I mean, it's fast. It's really, really fast.
So you
And yeah,
stand up the steel before and then print to
yeah,
it.
yeah. So right now we've been casting a footing
Uh-huh.
traditionally. Okay. Having your reinforcement extend out of the footing vertically, however high you want it to go,
Uh-huh.
and then print.
Nice.
And so our goal is to do a 30-foot wall coming up, and I'd love to compare it to like a human built, a traditional built wall, like have a race. You know what I mean? Like we had some guys come visit us that had that idea. I thought that was a cool idea, but just line them up and say like go and like see who can get it done and see whatever. But I mean, if you make them wait till they patch everything, the 3D printing is going to just slaughter them because you're not going to know if you've got good finish or not till you can pull the forms off, and you can't pull the forms for usually three days at the earliest. Maybe a little bit earlier than that, but
Yeah.
you got to give the concrete some time to set up, and gain strength. So,
Yeah. So you're doing a 30-foot long wall, and how tall?
we haven't decided yet, but we think about 6 to 8 foot high is what we're thinking.
Gotcha. Yeah, because like you said, formwork you strip off, and even if you got a job where it's like a B class finish where you don't need to smooth it, make it look pretty, you still got to patch tie holes and things like that. So you're subtracting days off, Tyler.
Yeah.
So yeah, that's awesome.
But it's not perfect, Seth. It's still got don't think it's all I'm all done.
Oh
Okay. I'm
no.
not all done.
Yeah. No,
So
if you're only doing 30-foot long, 6 foot high, we got ways to go, Tyler.
we
got
do. We do. And we got visions on how to do that, but just
Yeah.
like we're talking about carbon neutral concrete, we're not sure how we're going to do everything either.
Yeah.
So,
Yeah, but if you think about those two things are kind of tied together is if you're coming up with a process that is shorter than the standard process, that's less time that people and equipment and resources are out in the field. So you actually are reducing the carbon footprint of that operation.
yeah.
So yeah,
No, a lot. No, I think there's a lot that we can do with that, and it's not. I mean, the carbon footprint of the concrete that we're using is pretty low as well, and so I think it could be great. And right now we're using humans to drive everything, but there's automation we're already working on. We've got a lot of really cool. I mean, we've had electrical engineers working really cool on these guidance systems, and GPS is extremely powerful as well. And we just need some. Actually, we're looking for partners. So if people want to partner, want to help, want to learn more, I mean, I'd encourage them to reach out because it's kind of a lonely journey sometimes on when you're developing stuff for the first time, if that makes any sense. So
yeah, no, it makes total sense. But I'm sure there's someone that'll listen to this, and I'll make sure I put a link to your contact information in the show notes so we can reach out. Yeah, I think this is a good spot for us to stop the conversation today, Tyler. I will definitely lead everyone to your YouTube page. I'm already a subscriber. I'm actually on there right now. I was trying to count how many videos you have on there, and I lost count. There's too many on here, but I definitely, for folks, even for guys and gals that have been in the industry for a long, long time, you got to check out his YouTube channel because there's things in there that warm weather concrete, cold weather concrete, air and train concrete, those things that we think we know everything about. There's some good reminders in here of that, of the basics of that stuff. And it's awesome. It's an awesome YouTube channel, Tyler.
thank you, Seth. I do think education is so important in our industry. And if I can give somebody a 5-minute little bite that explains something kind of complicated, then that can save them, and a lot of people can watch it again and again and again. So again, youtube.com/Tyler Lay, Ley is my last name. You can find me. You can also find my webpage at www.tylerley.com, and that's kind of the gateway to a lot of different things that I'm up to and what's going on. And yeah, man, I love it. I love it.
Yeah, thank you, Tyler. Thank you for coming on. We'll put all that stuff on the show notes so everybody knows how to get a hold of Tyler and send him some money for his 3D printing machine.
That'd be cool. And Seth, let's do a round two sometime.
Oh,
Okay.
definitely. Thank you. Yeah, that'd be great.